Alright, let's make a little video reviewing solving absolute value equations, inequalities, and also we'll take a look at some absolute value graphs. So this is simple, right? A couple restrictions before we start. If you have things on both sides other than your absolute value sticks on one of the sides, you have to move stuff around algebraically. So what do I mean by that? If you had 3x in your absolute value, right, and there was a 7 plus that in the front of it, right, you can't start solving this twice yet until you get the sticks by themselves. So before we start, keep that in mind. On these first two questions, because we have everything on one side in the absolute value sticks, we can start solving this twice. If not, like in this case, you would have to do -7 on both sides. Once you have absolute value sticks only on one side, like this, then you can start solving it twice. Once with the number positive, and the second time with that number over here negative. That's how you solve it. The only time you don't solve it is if when you get the absolute value sticks by themselves, like this number's already negative. If it's already negative, then there's no solution to it because nothing in these absolute value sticks can end up being a negative number. So let's start. Let me just clear this up. So these are pretty simple. The first one's pretty simple because the only thing you have to do is divide by 3 first, divide by 3 on the other side, but this time you're going to put a negative on that final number. So with these questions, you're going to get the same answer twice, but one's going to be positive and one's going to be negative. So those are your two solutions. Remember, these quadratic functions create a V shape. So technically, you can get two answers. So let's keep this moving here. Same thing here, but you're not going to get the same number twice because there's more terms inside of your absolute value. So we're going to start solving one side first as is with the number positive, and the second time we'll do the same steps but with that number negative. So plus 5 on both sides first, bring down 2x equals 26. Now divide by 2 on both sides and we get the first value for x. X equals 13 positive there. Same steps on this side, add 6, but your value is going to be different because you get a different result. So if I add, I don't know why I put plus 6 there. I'm supposed to add 5 to both sides. Now we get 2x equals negative 16. Divide by your coefficient as always at the end if there's a number touching your variable, and you get x equals negative 8. So again, you get two answers, right? Unless that last number is a negative, and you're going to see it happen on the next page most likely. So here on the left side, right, I'm going to already tell you that this is no solution, right? Before I show you why, just understand if on this side all you have is a negative value and on this side everything is inside of the sticks, then there is no solution. So let's understand what the two steps are to solving this are minus 16 on both sides of the equal sign. That needs to be your first step. Now bring down 4, absolute value, x plus 5 equals negative 16. Now, we still don't have only sticks, only absolute value sticks on the left side, so we divide by 4 because when things touch, that means multiplication. So the opposite of multiplication would be division. We divide here, and now we have x plus 5 in the sticks equals negative 16. At this point, if that number is negative, stop working. It's no solution. Now on this side, you think it's going to be no solution when you subtract 40, but there's another step. You have to divide. A negative divided by a negative turns it back to a positive. So let's do that one down here since it may lead you to select no solution. So first we subtract 40 from both sides of the equal sign. Bring down negative 2. Absolute value x plus 8 equals negative 40. Now we divide by negative 2 to eliminate it. Now we're ready to solve this twice. X plus 8 equals positive 20. And x plus 8 equals negative 20. So same steps on both sides. You're just subtracting 8. But on this side you get 12. And on this side you get negative 28. Alright, hopefully this helps. Let's keep it moving. Alright, now a word problem, right? There's a key to it, right? A hint that tells you when it's an absolute value equation. And that's when there's an above or below or within situation, which means they don't know if something's higher or lower than an actual value. So that leads you to get two answers, a higher and a lower value than what you see. So same concept when you get to margin of error later in chapter 10 in the data chapter. Margin of error is the same thing I'm showing you here, but with the percentages that they give you to start with. So let's first of all underline the word here that tells us this is an absolute value equation versus a linear equation. I mean, they give us the equation on this question, but on the next one, you have to know this is an absolute value function. They don't tell you. And look at the answer choices. They're in inequality format. That's just because when you have two answers, the actual value can land between those two answers. So the answers are in inequality form. So we'll get to the bottom section in a minute. Let's set up the absolute value equation and remember what these values are here. So the word that we have to underline here is higher or lower or above and below, within. Any of those phrases or words mean, oh, it's an absolute value equation. So now to solve the equation, right? You just solve it twice like we did on the previous page. But to create the equation, it's always x minus the original equals the variance. So again, we'll set this one up below before we solve the top one twice, because this is how simple it is. X minus the original thickness of 4.3 equals positive or negative 0.41. The positive or negative is just kind of a hint for you to get two answers from this, because it could be above or below. That variance is how much above or below is going to be. So this is simple now. We just solve it twice. X minus 4.3 equals 0.41. Once we're done solving that, we solve it again, but with that 0.41 negative. So the step on both sides is add 4.3 to both sides. And that'll give us two answers. On the top one, we get positive 0.41 plus 4.3, which gives you 4.71. So already we can eliminate these two choices. And down here, negative 0.41 plus 4.3 leads you to subtract and keep the sign of the bigger number. So it's a positive 3.89. So the answer is D here. Alright, let's kind of solve the top one here twice. Plus 96 plus 96 gives you 108. That'll be your maximum value. And now change that 12 to a negative, and do negative 12 plus 96, and you're really just subtracting it. So it has to give you 84. Make sense? So if you have to set up the equation yourself, that's an absolute value equation. X minus the original equals the variance. Alright, let's keep it moving here. So this is just creating a simple inequality, and I included it here so that you understand this is not a two variable inequality that will be on a graph. This is a regular simple inequality, because the only thing you're looking for is how many cookies to bring. There's not somebody selling cookies to make money and that profit can keep going up in a straight line. It's just a regular inequality for a teacher to know how much to bring if they're going to eat 7 cookies themselves on the way to work, and they're going to give 3 cookies to each student with 120 students total. So really all you have to do here is set up x needs to be greater than or equal to 120 times 3 candies each plus the 7 that I'm gonna eat. This is gonna ensure that I brought enough. So really you can just simplify it as like the answer, and that'll be a correct answer for an inequality. The only time you don't set it up like this is if there is a situation where there's a slope and a y-intercept and it's increasing or decreasing in a 2 variable situation. Here there's really only 1 variable because we know everything else. Now let's get to some solving regular inequalities, right? When it comes to solving an equation and an inequality, it's the same process. The only difference is that you either flip this inequality or don't flip it depending on what your work leads you to do. So I'll review that right now. If you ever divide or multiply both sides by a negative, that's when you flip the inequality symbol. So if this was an equal sign or inequality, it doesn't change the steps, right? But your answer is completely backwards in terms of graphing if you forget this step. So let's start with solve the one on the right first with a positive, and then we'll solve this one here with a negative. So the steps would just be distribute, subtract 2 from both sides, and now last step is always division. Here you're dividing by 2, and we get x is less than 4. No flipping because we did not divide both sides by a negative. I can't repeat this enough. If you get a negative answer, that doesn't mean you flip it. Only your work makes you flip it. If you, while you're solving, you divide or multiply both sides by a negative. So let's watch it happen over here. Negative 2x minus 2, bring down your less than 10. Now it's a 2-step inequality, just like a 2-step equation. Same steps as you would do if it's an equal sign. But now at this point, when you're dividing both sides by a negative, that's when you grab that inequality symbol and flip it around. So the graphing, if you forget this step, is going to be backwards. So this gives you x is greater than negative 6. We flipped it. So what does that do? It changes the inequality in the answer, right? And it also changes the graphing, because when you graph on a regular number line, right? Let's say this is your negative 6 here. First of all, you put a dot here. Do not shade it in unless they have the equal to stick under the inequality symbol. So this one does not get shaded. And now you think open or close to my variable. If it's open to your variable, it means greater than, so we go to the right. If it's closed, we would have gone to the left. So if you forget to flip it, you're going to go to the left and choose the wrong graph. So just make sure you remember that one difference between equations and inequalities. Now let's finish these last two off because they're a little bit different. Same concept, just a little bit different in terms of what they are asking and the style of question. This here has 2 inequality symbols. That's a compound inequality. So there's 2 types of compound inequalities, right? Ones that their graphs go towards each other, or in this case, the graphs can go away from each other or the same direction. So if you see the word or, it has to be graphs that go away from each other or same direction. And if you see it all together like this, or with the word and, then the graphs are just going to go towards each other. Now the or is easier to solve because you're just solving them separately with the word or between them, and then you can choose your graph. So here you're just dividing by 6. We get negative 5, no flipping. Divide by 4 here, no flipping. We find the graph that's less than or equal to negative 5, which would look like that, and greater than or equal to 3. Notice they go away from each other. So over here, when it's all together, you're trying to get the variable by itself in the middle. So really, same process as solving a regular inequality or equation, but whatever you do to the middle, you do both sides. So that gives you negative 6 on this side, 3m by itself in the middle, negative 3 over here. Last step to leave m by itself in the middle will be dividing by your coefficient, which is 3. And now we have our answer, and we can graph it if we want. I'll just sketch it real quick for you. Negative 2 here, negative 1 here, towards each other. Now this side does not get colored in because it doesn't have the equal to, so just make sure you don't forget shade it in when it has the equal to stick. Don't shade it in. And when I say shade, I mean open or closed circle, right? Closed circles when you shade it, open circles when you don't shade it. All right, now let's just look at these last two pages in terms of two variable equations, right? Like y equals absolute value x plus or minus something plus or minus something, depending on where the graph moved. So all you have to remember here is that the parent function is right here on 0, 0. And that would be y equals absolute value x with no numbers on it. So all you have to do to really write an equation of an absolute value function is see where it moved in terms of starting location 0, 0. Where is it now? So if you think about it, right, this is really all you have to do. From 0, 0 to this spot, it was left 1, which is plus 1, x plus 1 in the sticks. Just like when we do vertex form of quadratic functions, same thing. The movement is the same. Inside the sticks or the parentheses is left or right. Outside of the sticks is up or down. So in this case, it's left 1, down 3, which would be x plus 1 in the sticks, minus 3 after. Now the only thing missing is our a value in the front, which is our slope in this situation. So just find the slope of this graph. Up 1, right 1 gives you 1 over 1, which is 1. 1 next to the absolute value you don't have to write. So your equation is just like this. So let's try the same thing over here. We have y equals a 1 slope again, so I don't need to put the 1 there. And now this spot would be to the right 3, which is x minus 3 in the sticks, plus 1 because it's up 1. That's it. That's my equation. Let's try two more on the next page and we'll stop this video. So on this one, right, the movement would be left 4 and that's it. So it lands right here on the x-axis. Now the slope is 1 over 1. So up 1, right 1, up 1, left 1 because it's symmetrical. And you can graph it yourself. Instead of writing the equation, you can do it in reverse, graph it yourself. So same process here. This is left 4. I go to left 4. But the slope this time is negative 2. That's down 2, right 1. Do the opposite, down 2, left 1, so you can create your symmetrical V shape. That's really all you need to know, and that helps with quadratic functions as well in terms of vertex form. Also, you could think about the vertex. Let's go back to the previous page to use two numbers. Also, you could think about the vertex, right? The same way you do in vertex form of quadratics. The number in here changes signs, so negative 1. Over here doesn't change signs. Negative 1, negative 3 is your vertex. And if you notice, that is exactly the vertex. So there's many different ways of doing it. I recommend you remember the movements or the vertex, which is the same process, and you'll eventually get to the equation a lot quicker than using another method like creating a table yourself. Alright, hopefully this helps. Let me upload this video for you and I'll just make another.